Fafa is what they'll say every single time, like a kick in the guts.
I'd run off and I'd cry.
Here comes Yob. Fafa.
When kids in the village would sing that in front of Dad.
Se soy
Oi, Sole. You get so angry.
Yo,
Yeah.
Tony, son, walk like a man.
Our sister would catch us wearing your stuff.
But I thought I looked pretty.
At dances in the village, I'd want to put on the Tulinga headdress.
Then, the whole village would stare. People would laugh. The light went dark, and I felt nothing. But I'd go to the mountain.
And dance by the waterfall.
Being free was a beautiful thing. If I leave, I'll take my roots with me. A piece of home to carry.
In my blood.
Hold on tight.
As I shift in the wind, I'll land and plant these pieces, and I'll grow. Walk like a man, Yopi. That's what Dad used to yell. No. I reckon I'll walk just like me.
Sao malosi ilelalolangi ai wangalo yatea uole sili sili ese olelangi e uina o savali ile pongisa ai salofa mai oia ole Lea ua o soe ola.
Hello, everyone, and welcome back to Inside Unreal, a show where we explore and celebrate everything Unreal Engine. I am your host, Dan Huddick, and today I have a wonderful guest who has come to talk to us about practical test automation in Unreal Engine. So let's go ahead and get him introduced. Andrew Fray, how are you doing?
I'm good. Thank you very much for having me.
Of course. For folks who aren't familiar with you, go ahead and let folks know a little bit about yourself.
So my background is gameplay programming and leading programming teams, and I've also done a tremendous amount of test automation in my career. And at the moment, I run a company who works with teams on integrating test automation and building build servers.
Perfect. And for folks who might not be familiar with the concept of automated testing and things like that, what are we going to be talking about today? What are we going to be covering? Let's kind of summarize the talking points. I know after talking to you a bit, we have quite a bit to talk about today. So
yeah, what I'm excited to show everyone is the tremendous amount of tooling that already exists inside Unreal so that people can catch bugs quicker and more easily. And there's a whole range of benefits that we're going to get into today around catching bugs quickly and fixing them fast. And test automation is going to enable you to do that.
Perfect, perfect. Well, we have a lot to cover, so I want to jump right in. But before we do, if you have any questions for Andrew here about practical test automation in Unreal Engine, please leave them in the chat in brackets, question, followed by your question, and we will gather as many of those as we can and throw them to Andrew throughout the show. But with that, I'm ready to jump in if you are.
Yeah, let's go.
Let's do it.
So we've got a couple of slides we're going to go through just first, because I want to explain to people what test automation is, but also why I think it's suitable and useful for games of all sizes. And we're going to start with this. This is an old adage from the wider software industry, right? That the longer it takes you to discover a bug, the more expensive that bug is to fix. That if you find something in post-release, it's not just 2 times more expensive than finding it in development. It's maybe 10 or 100 times more expensive than finding it in development. And it's less about the fact that fixing things in post-release is complicated. That is true. But a large component of why this number gets so big so fast is, I think, about the fact that the bug at this point is old. You made the bug in development. And that's going to last the whole lifetime of your development until you get over here to post-release. And that's why it's expensive to fix this stuff. And it's expensive because old bugs are expensive for a whole range of reasons here. Old bugs are expensive because they're slower to fix. Even if you are the one who worked on this system, if you come back and you have to fix a bug in this system, it's going to take you just a little bit to get your head around it, to understand what that one-line fix is going to be, so you do the correct, most cohesive version of this fix. If you were fixing this thing as soon as you created this bug, you'd already have that system in your head, and it'd be really easy for you to get back into it. It might even be the case that the person who worked on the original system is gone, and now you're going to have to spend time understanding someone else's code before you can figure out what the perfect one-line fix is. Beyond that, it might be more complicated to fix. There might be bugs that now depend on other features of the game now depend on the functionality of this bug. So you fixing it is going to have cascading effects. It might be that the perfect version of this fix is a complete refactoring of this system that you don't have time for. So you're going to have to do some kind of bodge. And if you could capture these issues early, then you wouldn't run into them. It could be that there's buried bugs. It could be that, for instance, if level 4 is crashing, and it's crashing for a long time, as far as you know, there's one bug in level 4, which is that it crashes. As soon as you fix that bug, you might discover countless bugs behind it that you couldn't see before. So there's risk from having these bugs in your code base for a long time because they're obscuring what's really going on. And not only that, but there's a day-to-day cost as well, where you could be disrupting other people. If that level 4 is crashing for a long time, then people who need to go into level 4, artists and designers who need to get in there, will have to go and do other stuff, or maybe they have to do a bodgy workaround. They have to do all this stuff, which is going to impact them and their productivity. So it's not just the cost of finally fixing a bug, it's also the added cost, the tiny bit of friction, the pennies and cents of friction that you'll have every single day that this bug exists in the project. And so that slowly all adds up to mean that the longer a bug lives in your code base, the more and more expensive it is, and the more money it's costing you, and that is money you could be spending on making your game better. And there's a really good metric in project management that I really like when it comes to bugs that I think is more interesting in many ways than total bug count. People focus on our project's got 500 bugs in it, and then tomorrow it's going to have 400 bugs or whatever. I think it's more interesting to think about mean time to resolve, MTTR. This is a stat that represents the average time it takes from when you create a bug to when the bug is fixed and seen as resolved by QA. And it's not the time the bug was found, it's the time the bug was created. I think there's a quality of life difference between a project that has 1,000 bugs with an MTTR of 2 weeks versus a project that has 100 bugs but an MTTR of 3 months. One of those games is shipping in 2 weeks, even though it's got more bugs, and the other one isn't. So I think it's almost more interesting for folks to focus on MTTR, to focus on this. How fast can we find these bugs? How quickly can we resolve them? And if you want to resolve them quickly, first you need to find them quickly. And to do that, we can do that with test automation. And we've mentioned this a bunch of times. My definition of test automation is code that automatically verifies a feature's behavior. And there's a lot of different things that this can mean. What we're not saying is how many tests you have to write in your project. What this doesn't talk about is what areas of your game that you test, or how big your team is, or what genre you're working on, right? All we're saying is test automation is a tiny bit of code that automatically verifies a feature's behavior in some way. And we're going to see an example of 4 or 5 different automated tests today. If you can use that, if you can execute it quickly on your build server, then you're going to catch bugs quickly. And we know that if you can catch bugs quickly, you're going to see benefits. So automated testing is actually, it's cool not because of some academic purity reason that automated testing is cool. It's cool because automated testing catches bugs faster and saves you money and time, which you can spend on other stuff. And one last thing I want to point out, because people get concerned sometimes, is that automation is not a replacement for QA. Every single time I've worked with teams and integrated automation into their process, QA have ended that happier because they're freed up from doing monotonous smoke tests where they're launching the build every day and pressing A to make sure the character jumps and loading every level in turn and making sure level 4 is still loading today. They're no longer doing that. They don't have to do that. The machines are doing the monotonous work, and instead QA can do what they're really good at, which is destructive testing, which is qualitative feedback, which is exploratory testing. And just so everyone knows, what we're not talking about today is AI. What we're not talking about is coding agents or LLMs. What we're talking about is automated testing using techniques that have existed in the games industry for 15 years and then the wider software industry for 20, 25 years. These are, you may or may not end up generating these tests with coding agents if that's what you're into, but you absolutely don't need any kind of coding agent to do this stuff. As a quick example of a studio that's done a bunch of test automation, if you know anything about test automation, you know that Sea of Thieves went really, really heavy on it. They had this terrible experience where Rare as a studio are working on DLC for Kinect Sports Rival, I think it was. They wanted to make DLC for the game, and QA told them to QA this product, to QA this DLC will actually cost you more money than you're going to make from the DLC. And so from that point, for their next project for Sea of Thieves, they wanted to approach this from the situation where they would never be slowed down from releasing because of the cost of testing a feature, that they would be able to scale these features and working on a game like Sea of Thieves, which is basically an MMO, working in these large multiplayer areas, very complex games, very complex features with complex repo steps, and able to do that without worrying about how long it's going to take a small army of QA technicians to give a green light for a release. And this is a slide from Jessica Baker's talk at Unreal Fest in 2019. In automation circles, we call this the slide because it has such an impact on the automation industry within games, where you can see the traditional, that white line of Banjo and Kazooie nuts and bolts bug count, you might recognize from some of your projects. I certainly recognize it from some of my projects early in my career, of bugs piling up and up and up and up and up and up. And then you just try and churn through as many as you can once you pass beta. And you compare that to Sea of Thieves, which was just flat the whole time. Sea of Thieves never approached a bug count for a much more complex game, for a much bigger game, never approached a bug count similar to or exceeding Banjo-Kazooie at the point where Banjo-Kazooie released, right? At no point during development was it more than that. So they went all in. They made a large investment in terms of processes, in terms of training their whole team to do test automation. You don't have to go all in to see these kind of results, but I want to show you what's possible if you do keep going this route. And before we dive into the code, I'll give you one little sales pitch, if Dan will forgive me, of what I do with Automated Air for my company. We do a whole bunch of stuff. So we work with teams on consultancy. So if they're interested in doing more around build servers and test automation, we can help them figure out how to align their processes and how to where they should be investing their time. We do fractional build engineering, which is we help smaller studios who may not have time for a dedicated build engineer to create build services for them in a way that works for their smaller budgets. We do workshops and training, which helps studios to use tools that already exist in engines like Unreal to let them do their own test automation, and that involves learning about the tooling, learning best practices, and adding tests to their projects. So leaving them, we do that workshop, and then they leave with actual executing tests on their project that they can use. If you go to automatedaf.dev/workshops, you see there's some workshops up there right now you can have a look at. And we also finally do fractional QA engineering. So if you want someone to come and write test automation for you, then we can do that, either in short bursts or maybe a little bit over time. Okay, great. Let's finally look at some tests. We're going to start by talking about asset tests. So we're going to look at Lyra. You'll all be familiar with Lyra, I'm sure. But for those that aren't, this is an Unreal Sample project, an Unreal Sample FPS, multiplayer FPS project. It looks like this. You launch into the game, and then you've got a very classic Unreal tournament-ish shooter. And there's a bug with this version of the game that we're going to explore together, and we'll write a test, an automated test together to see it. So we've got our pistol here, and if I could find an enemy, then our pistol isn't actually, that's a friendly. Somewhere there's an enemy.
All of the gunfire.
All of the gunfire. Our pistol is not doing any damage. Well, that didn't help. I'm shooting as much as I want. I'm doing no damage to them. And in fact, we can go to, you can see it more clearly. This is a gym level. We're going to spend a bit of time in this gym level today. But you can see it's doing absolutely nothing to them. And we could sit here and debug it, and you should debug it the way I would encourage people to start looking if they want to start investigating this stuff is don't stop debugging. The automated testing does not replace debugging, but once we've debugged the problem and got to the root of the problem, we can then create a test to make sure that this problem never ever comes back. And the actual problem is, this is the B weapon instance for the pistol, the blueprint data asset that defines a whole bunch of stuff about the pistol. And one of the things it defines is the max damage range. And someone has set that to 0 by accident. And so our thing is no longer working. But the build server was happy to make a build. QA was happy to receive this build. QA was happy to play the game for ages until they finally noticed that the pistol wasn't, maybe they noticed relatively quickly for a bug like this. But you can imagine similar situations where someone might not notice for a while that there's a problem here. So let's create a test that helps us find this problem more quickly. And we're going to do that using a plugin that exists in Unity that some of you might be familiar with, or the data validation plugin. So if you're going to follow along using this VOD later on, then you want to make sure you've got the data validation plugin turned on in your project.
I'm glad you brought that up. Actually, we just had a chat and a comment in chat says we've been using the data validators for a while now. It's killed so many bugs before they even made it into the game.
Wonderful, wonderful. That's exactly what you want. And the UI of it is really nice as well. For those of you who haven't seen it yet, you're going to see it soon. So in Rider over here, we have the we want the Lyra ranged weapon instance. And this is going to be, there's going to be a lot of C++ today, but I'll show you in a little bit how to do data validators with blueprints with some caveats. So this is a U object, which means, because it's a U object, that means we can just add in a public, a public function here. I'm going to kill Unreal. Public function here that we can implement. And within that implementation, all we have to do is check on our, probably have to add a reference. I'll copy it for my example, that's easier. Yeah, so here in our is data valid function, we get past a context and we can check, is our max damage range less than or equal to 0? And if it is, we're going to add an error, and that error is going to say it should be greater than 0. And that's all we have to do. And now we've got some validation. We can extend this over time. It wasn't a time-consuming thing to set up. And then in the future, if we get more errors in the ranged weapon instance, we can add them to this validation. And this will hopefully, when Unreal reloads, allow us to see straight away the validation problem we got with the pistol. Where have you gone? Where you gone? There you are.
It's hiding.
Oh,
Eh,
okay, we're good. We're good. We're good.
there we go.
Okay, good. So if we, open those. If we go back to our weapon instance, we've got it set to 0 now. If we make a change here, we'll set it to minus something and we'll save, and we instantly get a pop-up. This wasn't happening before. We're going to get a pop-up, and that pop-up's going to say max damage must be greater than 0. And that's going to hopefully warn whoever's working on this, before it even gets to the build server, it's going to warn them, hey, there's something you need to be careful of here. We've got a red arrow up here in the corner as well. We've got a whole bunch of ways that this UI, this UX is stopping us committing any kind of problem here. So we can put this back to 100, compile it, and now everything's ticked. And when we go back to the game, we should now see that our pistol is going to do some damage. I mean, there's a skill issue here as well, right?
You can't patch that out.
Can't patch that. Well, he's not dying.
Oh.
But it is doing damage. It should be at least if it's that's fine. That's fine. That's the pre-existing ones. If it's still not working, that's not my bug. No, it's someone else's bug. So that's really simple, really straightforward validation there for pistols, for code you own, right? For C++ that you own, you can implement that function, is data valid, override it, and then add your own validation here. This is useful, but it doesn't work in two situations. First of all, when you have blueprint that you'd like to add this validation to, this is not a blueprint exposed blueprint event, so you can't do that. And secondly, you might not own this C++. A very common use for data validation is to make sure that your content is named correctly. You can make sure that you've got an L underbar before your levels and SM before your static meshes and everything. And you might want to do other stuff, like say every mesh within this folder, every static mesh asset within this folder, I would like it to have the collision turned onto this layer, for instance. You can set up data validators to do that, or you'd like to set up data validators to do that. But the static mesh asset is not a C++ class you control unless you're going to go and start doing some diving into the Unreal Engine source. And you don't really necessarily want to have to create your own derived class just so you can add some validation. So there's some things we can do here. I'll show you the blueprint version first. Let's put it in a suitable place. Let's put it in weapons here. And we're going to create a new asset. No, I don't. It's because what are you doing to me, Unreal? Add blueprint casts. And we're going to search them all, and we're adding data validator. Here we go, editor validator. We're going to add an editor validator, and we'll call it weapons editor validator. And then this is a normal blueprint class. It has functions to override. The interesting one is can validate asset. In can validate asset, what we want to say here is we want to try and highlight all of the weapon instances. So we're going to try and cast to weapon instance, cast to Lyra, doesn't matter which one, let's say ranged weapon instance. And if the cast failed, then we'll say we'll return a value of 0. And if the cast passes, then we'll tick it. And so now this validator will start trying to validate weapon assets for us. And then to write the actual blueprint to validate the asset, we need one of these functions to override validate loaded asset. We need to cast this again. And then once we cast it, if the cast passes, what we're going to do is have a select here. We will try and get the max range. This is the problem. Max range must be greater than or equal to 0. No, in fact, we want it to be greater than 0. Greater than 0. And if that's the case, if it's true, then it's valid. And if it's false, then it's invalid. Okay, so we compile and we save, and this should work. We're going to get the, in fact, let's validate bullets per cartridge so we can see two things do different things.
We're getting multiple people in chat saying, one, didn't know this existed, and two, I've been using the engine for 5 years, and I've never seen this tool in use. So,
this is the thing. This is the thing that everyone discovers when they're working on Unreal, right? Is that you will, at some point, multiple times on your project, you will spend 2 weeks writing a system, and then moments before you commit it, you'll discover Unreal supported that. And there was already a system to do it, and you just didn't know about it.
it is the blessing and curse of something that is actively updated all the time.
Yeah. So now we've got this working on bullets per cartridge. So we're going to validate the bullets per cartridge is always greater than 0. And so if we change this to 0 and then compile and then save, it should pop up some validation here to say this is broken, to say that this is no longer good. Unfortunately, this doesn't work in Unreal. We're on 5.5 today. It doesn't work in 5.5, 5.4, or 5.6. But it's being fixed. But it means that if you want to do blueprint validation, you need to extend your own C++ class to do this for you, or write it all in C. Have a C++ base class that you can derive from with Blueprint, and then it will work with Blueprint, or you need to do it all in C++. Hopefully it will be fixed relatively soon in the next version, but that's how you would do it. And the interesting thing is here is that, so we were validating our bullets, our ranged weapon instance, but we could be validating multiple things. We could be validating static meshes, like I said. We can validate levels themselves. So let's look at the next example. So here, one second. I have the way these demos all work is I've got a complete Git history, and I just go back and forth through the Git history to get the samples I want. Look at the code. It's nifty, but you just have to make sure you were getting the exact right commit. Okay. So the Lyra demos have player start points. The Lyra gym has 4 player start points. It would be a bug to commit a level that did not have any start points in it. It would behave in a way that you didn't expect. I've updated the gym now to have no start points. So we'll run it, and they'll see a print an error in the console. The player will still spawn, but the enemies will be missing because the game doesn't know where to spawn them. We can't derive from so here in the world outliner, you see there's no longer any spawn points. And we can't, because this is a level and there's no enemies, and we had an error in the console there, and some errors pop up when we quit because this stuff is missing, right? But we have to wait for runtime to discover that. It would be nice if we could somehow validate levels, but we can't. There is a U world, but we don't control it. So we need some other way of referencing assets that we don't control and validating them. And we just saw a blueprint version of that. And this is the C++ version or shooter maps. So this derives from editor validator, and it has the similar functions to what we saw before. So it has can validate asset to choose what assets we want to validate, and it has validate loaded asset to take that asset and check that if it's working or not. The implementation of those looks fairly reasonable. We're going to check the super. We're going to check that we've actually got an asset. And then we're going to see if the asset we're being passed is a UWorld. If it's a UWorld, then we know it's a level. We're also going to do some filtering. So up here, we've got the root folder of all the maps, shooter core / map /. And so we're going to check. We're going to check down here on line 34. We're going to check that the UWorld we're looking at is one of these shooter maps. And if that's true, if this returns true on line 21, then we'll eventually get to validate loaded asset. And then this does more work. So this asset is now loaded at this point. At this point, it's not loaded. So you can actually, it's relatively cheap to add a whole lot of assets to your game, as long as you don't need to load that asset to check if you should validate it or not. But once you have loaded it, in here, we can get the persistent level, we can start iterating all the actors, and we can look for actors of a type live where players start, and then increment a count. And then at the end, we'll say if that count is equal to 0, then we're going to fail the asset by saying level must contain at least one live where players start, but none were found. Players would have nowhere to spawn. Otherwise, we can pass the asset. Pass the asset here on line 62. And the end result of that is that we can now edit this level in some way. Boop, move that, and then save it, and instantly we get a pop-up, like we did before, saying at least one player start, but none were found. Players would have nowhere to spawn. And it tells you what caused this, and it should tell you what map this was on as well. So now we can go, before even committing, we can see this problem. If this gets as far as the build server, then the build server can run all of this validation across the whole project, and it can then fail the build and say, hey, we're missing spawn points over there. We've got 0 range on this pistol, and QA don't have to wait. QA don't have to get a build which is broken. They can instantly see there's a problem. They can see someone's dealing with the problem, and hopefully they get a new build fairly quickly. And that build will be all working, and they don't have to waste time chasing obvious problems. So that's asset testing. Let me get back to my slides. So we saw when we're writing asset tests that we get informative failures here. We're being told exactly what's wrong and exactly how it's wrong. It is wrong because the range is less than 0. It is wrong because we're missing spawn points. And we did that using the data validation plugin. If you've got a U object that you control the source of, you can just use isDataValid to do that, to check that. We saw the scene asset demo, and then within the scene asset demo, we saw that we can use uEditor-to-validator, so we can derive from that, and that will let us validate things that we don't control using can validate asset and validate loaded asset. And we saw that you can do this with blueprints. You should theoretically be able to do this with blueprints as soon as the fix is shipped in 5.7. We're going to have some time to answer any questions anyone's got in a second. Before we do that, because I am a freelance consultant, freelance consultants love matrices. And so here is my matrix for the different test types that we're looking at today. And we've got, in the column section, we're looking at how fast it is to execute in one column and how slow it is to execute in the other column. This is a really interesting thing. The faster your tests can execute, the more often you can run them and the more useful they'll be. So having things over here on the left is really, really good. And then also, as we go higher on this axis, we'll have more tests that are more specific. And down here, we're going to have fewer tests that are more generic. And you see what I mean by that when we get to those soon. But asset tests, if anyone hadn't guessed already, are going to be really, really fast to execute, because we're not running the game. We're just looking at ones and zeros on the disk. We're just checking things look correct given the expectations that we have. And that means we can create a lot of them very, very quickly. As soon as we have a bug, we should be trying to chase that bug back to some kind of data asset test, some kind of validator code that we can write. And I think in my experience, probably 30-40% of bugs, depending on the project, probably 30-40% of bugs, you could probably chase back to some kind of asset validator. If you do that, you'll quickly grow a suite of data validators and asset tests that are really rich and really plausible. They have a really good reason for existing because you wrote them to fix specific bugs. You weren't speculatively saying, I think this might break, and then never having that test break. You were instead creating tests that are always going to be useful because this thing might break again in the future. So that's asset testing. That's the first type of test we're going to look at today. Dan, do we have any questions or thoughts?
Yeah, we have a couple here. One is less of a question, but more of a comment that I think is worth addressing, which is people have a tendency to just immediately close those error windows because they get so used to them popping up all the time. If you're just working on your own project and things like that, like obviously the error window is there to let you know that there are things that aren't working. But in a lot of cases, especially early, you might be able to ignore some of those things. Presumably, if you have sort of validation in your pipeline, then this should become something that you are looking at more thoroughly, as you build and test and do all that sort of thing.
Yeah, it's one of the biggest challenges you'll face if you start to adopt test automation mid-project. And there's no reason why you can't adopt test automation mid-project. You just have to be aware that this is going to be a challenge of historical problems. Of you want to turn data validation on. You're like Unreal ships with a whole load of data validation built in, right? You can run it. We never did this. You can run this anytime you want from the Content Explorer. You can click on a folder and you can validate assets in folder, and that will run all of the data validators. Or you can click on an individual asset, and then in asset actions, you can click on validate assets, and then that will pop up if there was a problem. There's no problem with that asset in this case, right? So if you just decide to turn it on your build server, all of a sudden, validate all the assets, you might start producing loads of errors straight away. And it's just a case of you sitting down with a cup of coffee. It's probably actually going to take less time than you think to grind through all those pre-existing errors and fix them. The other thing you can do is do allow listing. So you can take the current errors that exist, pop them inside your build server, inside part of the build server to say, if you see these ones, don't fail the build. These specific ones, don't fail the build because they're pre-existing. If you see any new ones, do fail the build. And so that will keep people honest when it comes to, they don't have to sit down and go and fix everything, but it will stop them creating new stuff and making the situation worse than it is. But the problem of the original question was like, people were just going to see that thing pop up and then not pay attention to it. That's a process thing and a people thing. Teaching people that these are serious issues. And as soon as you start making the build server fail when these things pop up, they'll learn very quickly that it's a serious issue because they're getting pinged in Slack with someone saying, you've broken the build, come and fix what's happened.
Yeah.
But it's about communication, and it's about getting people on board with the aim here of making it cheaper for us to fix builds and therefore allowing us to spend more time on gameplay in the long run.
Absolutely. Another question, more of a comment we have. Well, it's kind of both. One of the tricky bits is keeping data that has not passed validation out of your repo. We use horde/swarm for this. Can't check into P4 if the CL does not pass validation. But is there a better setup for smaller studios?
I think the smaller studio best setup is just to not be afraid of letting your build server go red. I do think that everyone, if you're basically more than one person, you probably want a build server. And I'm not just saying that because I sell build server services, but I do think they're incredibly useful for keeping you honest and for saving you time. You want to be able to deliver builds to external stakeholders as fast as possible rather than having to churn your machine for 45 minutes to make a build. And in that situation, in a small team, it's perfectly acceptable for the build to go red. In fact, if you go a full week and the build was green the entire time, you were definitely making bugs because everyone's making bugs all the time, right? And it didn't catch any. So that's a signal to you that you need to put more validation and more automation into your build server so it can go red multiple times a week. And being okay, making sure that the team is not shamed, making sure that a build failure is not about pointing fingers and saying you messed up. A build failure is about saying, hey, the servers helped us here and caught an issue before we wasted QA's time, before we wasted each other's time with this. Let's react to it sensibly. Let's fix it quickly. And if there's repeated avoidable mistakes, then sure, let's address that privately. But in public, it's about thanking the build server for its service and fixing and reacting to that issue as fast as possible. And What was the core of the question? Have I drifted from the?
I think that was mostly it. They were just asking like, yeah, like what is the best setup
What's
for
the best
smaller studios?
Yeah. For smaller studios, if you don't want to go through a full horde setup, if you don't want to do pre-commit hooks, which is what they're talking about, then I think it's perfectly reasonable for even like a team of 20 to not do pre-commit hooks and instead trust the build server to just build main, commit to main all the time, trust the build server to build main, and trust your team and trust your processes to react to failures quickly and to fix failures quickly so that we can be sure QA are going to get a build from the overnight build run.
Yeah. One of the questions we had here was what happens with this code later once the game is packaged?
It all disappears. It all disappears. It's in fact, it lives inside an editor module.
Yeah.
Yeah, Lyra editor. So it doesn't get compiled. It doesn't get shipped in a package build.
Yeah. And then I haven't seen this one explicitly stated here, but I've seen a little bit of conversation about it, and I suspect we'll see it more as we kind of go through. Is one of the things that we're emphasizing here is like saving yourself a lot of time with catching these bugs early, but also building these validators also takes time. I can see folks maybe going like, okay, well, I'm just only going to build validators for like the stuff I expect we'll miss. And maybe you have a different take on this. I'm very curious to see your take on it. But like, I would almost recommend doing the things that you think you won't miss, and do those as well. Because in a lot of cases, a lot of the validation comes down to stuff that you expect you would have already caught, or you expect somebody would have caught. And because it's an expectation, if it slips through, then you're not gonna catch it. And usually it's the simple stuff. It's the little things. It's the things that you think that you have in the bag are going to be the things that you ultimately forget, because all it takes is one time of forgetting it, and then it doesn't work. You could do it right, 100 times, and then 101st, time you don't get it right, and then now it's a problem. So, any response to that?
Absolutely. You've only got so many tests. There's a finite number of tests that you're going to ship with your project, and it might be a very small number, and that's okay. Right? You don't have to commit to doing thousands of tests and think that's the only way you're going to see value. You're going to see value from a small handful as well. And you want to, if you know you've got a finite budget of tests, make sure that every single test you're producing has value. And there's a whole bunch of factors that can go into deciding what has value. I think it's a really, really good idea to make sure the obvious dumb stuff is caught. If level 4 is crushing, like do make sure you're catching that. If QA are going to boot the game, this is a great way to do this, is talk to your QA. If you're lucky enough to have QA, ask them what their daily smoke tests are. Because every day they'll receive a build and they'll go through a list of 5, 10, 15, 30 things. Ask them what those are and start automating those things, because those are the really obvious things. They don't want to get a build and then say, actually, the jump button doesn't work, or firing the pistol doesn't kill anyone. Capture those obvious things, that low-hanging fruit, to save them time as much as possible. And then the second bucket of tests you're going to look at are going to be the fragile areas of your game, the really, really valuable core pillars of your game. If your game is all about haircutting, giving haircuts to Pokemon, then you want to make sure your hair physics and your scissors physics work, your scissor mechanics work really, really, really well. And so you might want a lot of test automation around that. You might care less about the metagame. You might care less about the volume slider in the options menu, right? You don't necessarily need to put as much test automation around that. So what's really important to you? What's really important to the game? What's really important to QA in their daily tests? And then finally, what's really hard and off the beaten path to test? What's something that someone will notice, actually, this has been broken for 3 months because we haven't really been playing with this corner of the game. That's also good stuff. Like, it's really off the beaten path. It's really difficult to get into the right situation. Maybe it's a beat 'em up and it involves triggering some certain combo that's actually really, really hard to get the button timings right for. And so being able to have automation around that stuff to save people the hassle and to make sure QA can stay focused on what's changing right now, keep an eye on what's changing, and not have to constantly regress every single system in the game all the time.
Yeah, especially things that you'll do a lot of in the development. Like I think of the spawn point example is an interesting one, right? Because if you're making a multiplayer game with a dozen maps, that's something that you need to validate on every instance of those maps, right? So that's something that is going to happen a lot. It's going to be a thing where all it takes is like, yeah, you put all the spawn points on 11 of them, but you missed it on the 12th. that's an important thing that the validator
Yeah,
will
100%.
catch.
And a really common one, I've done this on a bunch of projects. There's been a very common bit of automation is the spawn point above the ground? Because
Yes.
it only has to happen twice, right? Twice in a 2-year project, a build gets produced and the spawn point's below the ground to be like, I'm going to spend the 5 minutes to write the automation to make sure it's above the ground.
Yep. Perfect. Well, I think we can continue on. We have a few more questions here, but they're more general questions. So,
cool. All right. The next thing we look at, I think automation, I think asset validation is a really great place to start. Right. I've put these tests in order of complexity and investment. Right. Data validation, you saw on a U object, is just overriding a function and adding an if case. Right. It can be really, really low effort to start adding data validation. Smoke testing is the next thing that I think gives you really, really high bang for buck, really, really high returns. If you only do these two things, I think you're going to have some good value. So we'll look at what smoke testing is and how we're going to use that to produce tests. And we're going to look at Spec, which is the first of, not the first, it's going to be the second we look at today. Unreal loves being Unreal, and it has 7 or 8 different testing frameworks within it. And data validation is one of them. Spec is another one. We're going to look at Spec today. And we're also going to spend the day, at the end of today, looking at CQ test, which is one of the more newer testing frameworks. But what is a smoke test? So a smoke test is some version of playing the game. It will, you'd want it to approximate what we were talking about before when your QA get their build and they have a certain amount of checks before they ever start looking at today's issues or today's new features. They're going to say, well, first of all, we're going to load into level 1 and make sure we can jump. And we're going to make sure we can pick up an item. And we're going to make sure we can change weapons. And we're going to do those things. And then once we've ticked that off, normally one person will do that. They'll tick it off. They'll announce to everyone to say the smoke test has passed. And then all of QA can start using this build. So we're going to try and automate some of that. This is the closest thing. I think people's preconceptions about test automation is that test automation is the game playing itself from beginning to end, right? It looks like QA using the game, and it isn't. Large parts of test automation are not that. However, this is the aspect of test automation that looks most like that. And what we're going to do is we're going to try and step through the game in a way that approximates a player using the game. And then we're going to be watching for weirdness. And what that's mostly going to mean is, were there any errors in the console? If there was an error in the console, then we're going to fail the test and we'll say it broke. So it won't be specific, not like data validation where it says, hey, the test failed because your bullet count was less than 0. No, it's going to say it broke because something's broken and we're not quite sure what, but you should go and investigate. And we're going to see that in a second. So I've loaded in the asset tests. Before we do that, let's talk about Spec a little bit. So you can, we talked about data validation a minute ago. We were looking at data validation, you did data validation plugin. Before I used the data validation plugin, I would write similar asset tests using Spec. And so what I've done is take the data validation that we just did, the exact same thing, and then rewritten it in Spec so we can see a little bit of what Spec looks like. So Spec is normally as a weird file name, it's spec.cpp, normally .spec.cpp. That's a convention. And then it's heavily macro based. So you start with a defined spec with a name of some class. This string is important. We'll see that when we get into game. And then you will always see a public void define here. There's no header file, right? The define spec macro here is handling all of the declaration of this class for us. We're going to just call, we're just going to implement define here. And when we're implementing it, what we're going to do is going to try and find all of the weapons in the project. For all of those weapon candidates, we're going to then run a test over them. And then we have this other magic function. This is a very spec part of the game called describe. So a spec test will often be made up of defines, describes, and then finally its. This is a pattern called behavior-driven development, which the authors of Spec really like. I do think it's really good as well. It lets you write these almost English fluent sentences about your test. So here we've got a definition saying it should have a max damage range greater than 0. And that's working. The it there is the thing we're describing. We're describing this weapon and we're putting its name on it. So it's a little bit convoluted, but once you get your head around it, we're going to define a thing, which is to describe an object of some kind, and then we're going to give some requirements on that object. And within this curly brace, this is the actual test itself. So the test itself is getting the ranged weapon instance, and then we're just going to assert test true when the max damage range is greater than 0. That's our equivalent to our Lyra ranged weapon instance. That's equivalent to this line here. So you can see it was more work, right? It was more. Where's my spec on? There's a lot of boilerplate here. Some of this will, as you make more and more, if you were to take this approach, as you make more and more spec classes, some of this becomes boilerplate, some of this becomes utility function. But the actual guts of our spec is just this line here. And when we run that, when we compile that and run that, we're going to get to look at a new window within Unreal called the session front end. And the session front end will list all of our automations, all of our automated tests, which includes spec. So we're not yet looking at smoke tests. We're just looking at getting the faintest bit of familiar with spec and how you use that and how it's different to data validators. So once Unreal comes up, come on, buddy. This is the best thing about doing live demos.
Oh yeah. Everything running simultaneously, and computers always love that.
So session front end, you get to from tools, session front end, right? And that opens this tab. And then this has got its own tab called automation. And then within automation, you can see there's an automated AF section there. That's part of our important string I mentioned there. So automated AF, edit time tests, asset, ranged weapons. If we unfold that, we see edit times tests, asset tests, ranged weapons, and then we see all of our weapons listed here. This is a describe section. So we're calling describe with weapon name, and that's what we're seeing here, the weapon names being described. And within those weapon names, we see all of the it calls, and we only have one in this case, which is here. It should have a max damage range greater than 0. We can tick all these, and then we can hit run, and it will run very, very quickly, just like an asset validator. And they all got a green tick, and the little window popped up to say they were all a success. So that's great. The nice thing about Spec that sets it apart from the other test automation frameworks within Unreal that exist within, we will see this automation window a lot. The nice thing about it is you can do almost procedural tests in the same way that you might use procedural generation at runtime to make a whole bunch of different wacky dungeons to explore. We can use almost procedural generation here to create more tests than we can imagine. So we're searching for all the weapons and then doing a for loop over them and then describing each one. And that means that as soon as an artist adds a new weapon, I will gain a new test here. The next time the game compiles, it'll have a new test, and that weapon will start being tested straight away. Having said that, the reason that I don't write my asset tests in Spec anymore is because it doesn't give you this nice UX of me saying, hey, max damage range should be -1, and then compiling and getting a red thing here and saving and getting a pop-up like this to say it's broken, right? You don't get that with asset tests. You have to know to come into the, yes, thank you. You have to know to come into the session front end. You have to know to come into automation. You have to know to come down here and run the thing. Great for the build server. Great if you want to very quickly see what tests are available. It's good for discovery, but it's not a great UX for artists or designers. So I don't tend to use it for asset tests. However, we can still use it for smoke tests. So we saw that The Lyra demo has this front end where you get a main menu where you can select a gameplay type, and then you select quick session, and then that will get you straight into a match. We're going to try and replicate that in an automated test. So we'll click a button and the game will play itself to the point of getting inside the game. And we're going to we've got a new test here called, so here's the defined spec. It's called front end smoke test, front end smoke spec. It's got a string here which defines where it lives in the automation window. It's got some member variables and member functions, but this is all boilerplate and support stuff. You don't necessarily have to worry about that. Here is our define. And in our define, we've got our describe. So we're describing the front end. We're saying that these tests are going to be about the front end. And we have this new function here. This new function is called after each. There's another one called before each. These are helper functions which let you run boilerplate code before every single test. So if once we have some its in here, every single time we run the it would run the before each, and then it would run the it, and then it would run the after each, and then it would do the same again for the next it. It would run the before each, the it, and the after each, and the next it, before each, it, and after each. And that lets you release any resources. It lets you reset any counters that you might need to run from test to test. In the game, I don't think we actually see anything. Do we? No, we don't, because we haven't got any its yet, so you don't actually see anything. But if we look at the gameplay, we want to be in front end. We're going to try and replicate this. We're going to try and replicate clicking on play Lyra, clicking on quick play, and then getting into gameplay. If we only do that, right? If we don't spend any time trying to make this bot play the game, we still have quite a lot of value here, right? We've still explored quite a lot of the code base. We've done a whole bunch of asset loading. We've asked a whole bunch of actors to initialize themselves and to start ticking. And we've done, and so that can give you quite a lot of coverage, and it can let you find issues. You're going to find a whole bunch of issues here by someone's forgotten to update a component reference on an actor that spawns inside the level. And so straight away, you'll see there's an error in the console and you can fail the test. We're going to do that. To make this work, what we don't want to do, and this is the trap some people fall into, is I just want to click on the button and they will look for ways to let them click on these buttons. You don't necessarily want to test the UI directly. UI testing is its own skill. And if you're just starting with test automation, what I would recommend you do is try and skim one level below that. So we've got the play Lyra button here. We can look at the blueprint of the widget and we can find start game button. And so we can see what is it doing. Rather than us trying to press the button, let's try and replicate what the button is doing. Hopefully it's just calling some next step in the process, some call a new thing. What it's doing here is finding the experience selection screen and then putting that on the stack, which is this widget. And this widget has the quick play button that we want. And the quick play button, what does that do? The quick play button is here. And this is the only edit I've made to a project that was not designed necessarily to have smoke tests run on it. This is the only edit I've made to make this testable, is that this used to go to here. And instead, I've split it up with a custom event. So this quick play now calls enter quick play, which is this custom event, which then runs all of this code. There's a lot of gameplay logic, which in a production game, you might say is not the best place to have that in the UI. But games are messy in real life, and that's fine. So we still want this to be testable. So what we're going to try to do is get our test to inject right at this point. What I wanted to do is pretend that it's pressed that button by calling this custom event that I've created. And that looks like this. We are going to, so we would normally have an it here. We've talked about this, which defines the test that we want to do. We're going to make a slightly different one. We're going to make a latent it. Some of you might be familiar with latent actions, which is Unreal's way of coordinating stuff across multiple frames. letting you do an action, waiting a few frames, doing the next thing, doing the next thing. Latent it is the same thing for Spec, so it lets you construct a test that's going to run for multiple frames, which is almost always what you want to do when you're having a runtime test like this. Data validators and asset tests are edit time tests. They run just looking at the data on disk. They don't need to boot the game. Whereas this test, because it's a smoke test, will by its nature need to boot the game. So we're going to have a latent it, and we're going to say boots into the front end with a clean console. And we're going to give it a timeout. Seconds. We'll give it 2 minutes. So if it doesn't manage to get to the front end within 2 minutes, then it will fail the test. And it needs a done delegate. So the way latent tests work is you pass this done delegate around, and when you've finished, when you know the test is done, you call done execute, and that tells the system that it's finished. And we're going to use test command builder. So that looks like this. This will allow us to construct this multi-frame test. This command builder takes a number of steps, and then you just ask to run the command builder. So we call step.build. We pass it the done signal. So it says, so we're asking shooter test spec to run test command builder, run all these steps, and then when you're finished, call done.execute, and that will mark the test as completed. So the interesting thing is, what are these individual steps doing? The first one is opening the front end map, and that calls a built-in helper function to spec called automate open map. So that will get us into the main menu. Then we're going to call start when, which means wait until is boot complete. So we're going to wait until that front end menu is fully loaded. And then we're going to give it just half a second for things to settle. Because if you stopped it straight away, as soon as that menu is completed loading, your actors will have initialized and constructed, but maybe they're doing a thing that takes them a frame or two to complete. And so you just want to let things settle in a smoke test. You just want to let things settle for just a moment. And by doing that, you'll be able to capture more issues. You see a log pop up that was going to always pop up, but you exited too quickly to do it. So this should get us to the point of getting into the front end, and it will sit there, and it will be really quick, actually. I should make that wait delay longer just so you can see it. In fact, I'm going to do that. Let's make that 10 seconds. And we haven't had to do, go on, sorry, Dan.
No, I was just gonna say it's also clever to have like the timers on things, because that'll also help avoid like basically indefinite load, right? Just wasting time because you don't catch it. Like that it's indefinitely loading. You've set the reasonable threshold. Be like, if it's taking longer than this, there's a problem. Just move on. I think that's really clever. That's something I don't think I would have thought of until I got into that instance. And I've been like, oh, I should have done that. That would have been smart.
Yeah, well, luckily, I think it's a required parameter, so you can't not do it in this case. Okay, so now we got a session front end, we got automation, we got automated AF, we got a runtime, and we can see front end. The front end boots into the front end with a clean console. We'll be able to tick that and run that. And then it's booted into the front end. It will wait there for 10 seconds. And then it should exit with a success. There you go. Ta-da. Ta-da. So now we need to press that button, right? We need to get to the next step of it, the next step of the game. And we want another test. And we want that test to run after the previous test runs. And this test is going to quick play into gameplay with a clean console. And we haven't had to write an assert to say the console was clean, because in Spec, in all the automation test frameworks, any kind of error log will fail the test for you. So you don't actually have to require it. And this one, I'll just copy and paste it. It looks a bit like this. So we've got another timeout. We've got another command builder with more steps. And these steps are saying, hey, start quick play for us. And then we're going to wait until we're in gameplay. And then we're going to wait 1 second for some more that's settling. And the starting quick play is getting the it's calling that blueprint event that we exposed, enter quick play. It's calling that on the screen. It's trying to find the screen with that name, which is the experience selector that we saw before. You can see it's listed there as well. So it's, you know, is this stuff that you necessarily bash out in 2 seconds? No. What you're going to see is that it also won't take you forever, right? It will take you an hour or two to get working for your game. And then once you've got good smoke tests, you don't actually probably need to touch them ever again. It's not like asset tests where you're continually adding to them. You create these smoke tests and then you leave them alone. So the fact that they take a little bit more setup isn't necessarily the worst thing in the world.
But it's also one of those things, right, where you're just kind of front loading the effort a little bit to save you way more time later.
Yes, yes. There's a very famous management paper. It's got nothing to do with software. It's about like oil processes. It's about processes in oil plants or whatever. And the paper's called like, no one gets credit for preventing emergencies that don't happen. And we saw this, everyone knows we saw this with coronavirus, where people did stuff. And then we saw it with the Millennium Bug. People do stuff, prevent a big issue. And everyone's like, what was all the fuss about? And it's a real problem with how to get your team to invest in automation, right? To say that we're going to put this upfront effort into adding this stuff to the project, and it's going to take a little bit of time, and it's going to take a little bit of process tweak and a little bit of a mindset change, but the benefits are going to come down the road, and we're going to be really, really, really glad we did them. And it takes vision and leadership to get that done in your team.
Yeah, I mean, if you spend a handful of days setting up all this validation, but it saves you 3 weeks of bug fixing, then that was worth it.
3 weeks of bug fixing, countless hours not interrupting designers because level 4 is broken, of them not having to do workarounds, not having to context switch to something else.
Yeah.
One important thing we need to do at this point, which is normally a big no-no in test automation, is we have to force a dependency between these tests, right? We can only run this second test if the first test has passed. Otherwise, we won't be in the main menu, so there's no point trying to click the quick play button. And so we'll put these, because in Spec specifically, Spec will run them in alphabetical ordering. So if we just put a 1 and a 2, then we know for sure it's going to run this one first and then the second one. Normally in tests, in automation, it's seen as a big no-no to have dependencies between your tests. You want to be able to find an individual test and run it straight away and not have to worry about, did the test before it pass or fail? Just want to run that one test and see it pass. It's normally a really bad thing to have these dependencies. But with smoke tests is the only time where you definitely need these dependencies. So now we can look at our smoke test. Yeah, we've got one. Oh, I see. I shouldn't have used a dot. I should use a colon or something, but whatever. Because it uses the dots to do the nesting. Whatever, it's fine. If we tick these both and run them, we should get to the main menu. And it's still waiting for 10 seconds because I didn't take that out. And then it should get into the experience thing and then exit straight away because I didn't put 10 seconds there. But trust me, it worked. And then the final step of this smoke test is to sit in gameplay. So this gets us, this previous test gets us, I'm going to jump to my pre-prepared version. So I've got the proper colons and I've got rid of the time step. The third test here just sits in gameplay. So we've got to gameplay, and we could, some games are lucky, you have a bot that you can easily hook up to make it play the game, but I wouldn't worry about the cost of doing that. You're going to get quite a lot of coverage out of this just from the fact of booting it and sitting in gameplay. Maybe you press forward on the analog stick, just make it walk forwards or something. And you're going to exercise quite a lot of gameplay logic by doing that, quite a lot of the blueprints in the level as well. So this one just sits and it waits for 3 seconds in gameplay. And if that's done, then it passes the test. So let's see that whole thing put together, that whole smoke test.
Yeah, we actually had a question a little bit ago, which is how would you architect your game so that you can drive your player character for tests? I know some companies do this with an AI controller, but I wonder if there are other ways. Sounds like
Yeah.
you're kind of loosely talking about right there.
Yeah. And it will be useful if you can do it cheaply. If you can do it pragmatically, then it's very useful. Even if all you end up having is the ability to manually script, like walk forward for 2 seconds, fire the gun, right? Even if it's not really a smart AI, it's just going through repetitious steps, that's still got value. And the secret there is the same secret that people use in writing AI. So the shim you want, the thing you want, is called a yoke, and it's a layer that exists between the input system, between the physical controller, and between the character CPP that's reacting to those inputs. So you need to make that CPP take an input that's some kind of F data struct that's got like a bool for jump and a vector2 for the analog stick, right? And then you have a layer of your system that takes the input from the input system, turns it into one of those F structs and passes it to the character. And then your test system, when you write your tests, can construct any number of those F structs that it wants and then pass them to the character itself. So both ways, you get to either drive it from the controller or you get to swap that yoke out and instead insert an automation yoke that'll make it do certain things. I've had great success in games by just doing a slightly more advanced version of walk forward for 5 seconds, press the shoot button, and you can write quite a number of useful tests that way. And that doesn't have to be a big refactor to get that done. You probably also, many games have structured themselves this way anyway, because it's useful for writing AI. All right, let's see it run. Don't do that. There you go.
While this is running, we did have a question. Somebody was asking, how are you drawing on your screen?
Oh,
tool are
that's
you
called
using?
Zoom It.
Zoom
It's,
It. I think we had that another person use Zoom It just the other day. So
yeah, if you get the Microsoft, what are they called? Power Toys? Microsoft Power Toys, which you should get anyway because they're very good. They have got a whole bunch of stuff in it, like advanced pace, like this command prompt where I can like search all my apps. That comes from Power Toys. It's an official Microsoft thing. And one of the things inside it is Zoom It, which has a whole bunch of really useful stuff for presentations. Like I can even zoom in. I can zoom in, I can
beautiful.
circle stuff. I can do arrows. I can do, I can't remember how do you do it? There's boxes. I can't remember how to do them. There's a whole bunch of stuff. I can set timers when I'm in a thing. I can write text. It's really good for when you're doing demos and when you're doing training.
Yeah, very cool.
Anyway, yes, we saw the smoke test run and we've actually seen it fail. So we've got a failure here. It took 12 seconds to get into gameplay and it's failed because it detected an error in the console. And the error it printed inside the automation window for us here. And it's saying, it's a failure here that's saying failed to load asset, IMC default KMB. Now this is a bug that shipped with Lyra itself. And it's not a complicated bug, but there's a missing reference in the input system. What was it called? We just had it on the screen. IMC default KBM. Yeah, IMC default KBM. Why can't I find it? Here we go. No, that's not the one. That's still not the one. Anyway, I'm going to find it now. I want to find it now. It lists the name of the asset. I'm just looking in the wrong place. Failed to load asset. IMC default KBM. IMC default KBM. That's what I was looking at.
Yeah.
IMC default KBM. Is it because I'm in the wrong place? All right, whatever. Let's. Oh, I've got the actual path here. Okay. Shooter core content experiences.
And there's game.
Shooter core content. Experiences. Shooter game shared input. There you go. This one. This one. There we go. Right. Yeah. So someone's forgotten an asset. That's all that's happened.
Mm.
Right. And that's a null thing. And so that's causing a bug. And so we can just delete this properly, or set it to a different, I think it probably should be that. And then when we run the tests again, we should see it all pass this time. So already that's showing value, right? Like someone could have cleared that asset by accident, and you could add some data validation. In fact, we'll get to that. Yes, and now they're all passing.
And that could happen
exclamation
for
mark.
any number of reasons, right? Like could
Any
be
number of
somebody
reasons.
forgot to put it there. Could have been that there was something else in there at one point, and then that asset got deleted. And there's so many different reasons why that could happen.
Yes, yeah. But now your build server can react and say, hey, something's not right. There was an error. Let's go fix this straight away. Because you let that through, you let that build go through, and all of a sudden, in this case, it's working. I don't know why it's working, but all of a sudden it gets to QA and they can't actually do anything. The input system doesn't work at all. And then they've wasted their time. They have to wait for another build for another 12 hours or something. So that's really good. And it's actually really good demonstration of what you should be doing, right? Because you could follow it's a smoke test, which means you can see the smoke, but you can't see the fire, right? It just says there's a problem. And so you want to normally follow it up with a fire test. In this case, maybe you want to add some validation to say there should never be a null entry in our input system asset, in our LAS, right? There should never be a null entry in there. And we can set up data validation. So if anyone tries to save it, then they can see it straight away. And if it gets to the build server can also run a much, much, much faster test. Rather than waiting for them, that took 11 seconds for it to run that test. And that will add up over time, right? One recent project I worked on ended up having about 30 minutes of smoke tests on the build server. Anything you can do to take that and move it into a faster, more specific test, not only will the build server react more quickly, but also it will react more informatively. It'll say, hey, the test that verifies there's no null values in our input code, that's broken, which tells you exactly what to do and exactly what to go to fix it. As opposed to, hey, the smoke test is broken, you're going to have to go and look at the log and figure out why that's happening and who caused it. Much, much better. This is a really good fallback, but it's not what you want to rely on. At the start of your project, you're going to see this fail more often. You're going to still see the smoke tests fail more often than not, and that's going to drive you to create the fire tests. And then slowly over time on a healthy project, you'll know you're doing it right if you start seeing the fire tests fail more often than the smoke tests. And by the end, hopefully the smoke tests are hardly failing at all. Wonderful. I'm going to skip that. Yeah, I had a concrete example of that, of like seeing a bug in the smoke test, going and creating a data validation test to catch the bug earlier. You all understand it. I'm sure you get it. It's fine. So that was smoke tests. What we're looking at here is a test that's slower to execute. It's going to take time, 12 seconds, as opposed to a fraction of a second to run all of the data validation in the whole project. And you're probably going to have relatively less of them. It's going to take you, all you need to do is get into the main level. Maybe if you've got multiple levels, it's going to load all the levels, but you're not going to spend a tremendous amount of time writing a huge number of smoke tests. They're also going to have general conditions. They're going to say, hey, is something look a bit iffy? Was there an error in the log? And what you want to do is be, like we discussed, if you see the smoke, follow it and add a fire test after it. Yeah. We looked at Spec, which is one of the test frameworks that comes with Unreal. We saw how it uses a behavior-driven development approach, which doesn't mean anything apart from the fact it has those describe it format. It's a very common thing. If you Google behavior-driven development, you see this a lot. It's great at parametric tests, at these procedural tests, where we can create multiple tests for all the assets that we can discover, all the paths in the game that we can discover. We don't have to know beforehand exactly what we're going to test. We just need to know the flavor of the thing we're going to test. And then on our quadrant here, we saw asset tests in the top left. They're going to be fast to execute, and you're going to have a lot of them are going to be specific. And then smoke tests are going to sit in the opposite corner, when they're going to be slow to execute, 10 seconds, 30 minutes, but you're not going to have many of them, right? You're going to just load every level in turn. Maybe on other ideas for smoke tests I've seen include loading every enemy in an empty level, spawn that enemy, hurt that enemy, kill that enemy, despawn the enemy. For the player, load every weapon, fire every weapon, wait for that weapon to reload, and do that just to make sure that that asset cycle can get fully exercised. And you could do that for a few different classes of assets and a few different classes of blueprint in your game, but you still will not have hundreds and hundreds of smoke tests. You'll have a dozen. And that's it for smoke tests. Any questions from the chat?
Yeah, we have a couple here. One of these is a little more general, but I think it's worth kind of talking about here. Is any best practices you'd recommend for code coverage with UE tests? And how do you decide what's worth testing?
So code coverage can refer to a specific class of tool within software engineering. A code coverage tool is a tool that tells you, hey, a certain percentage, it'll sort of run all the tests in your game. And then when it's running those tests, it'll be tracking what lines of code have been exercised by those tests. And you'll be able to be given a metric. You'll be able to say, hey, 50% of your game is covered by tests. And you can work, people can use that metric and they can work over time to raise that number. Personally, I don't put any weight in code coverage as a tool, as a metric. I think that it's too easy to game it. I think it's too easy to get false confidence to say, hey, half of our game is tested, when really maybe they're rubbish tests, or maybe they're not testing the thing you expect them to test. It's just that the code executed. So it's much more interesting, I think, to focus on what we were talking about before, which is pragmatically looking at the value of the test you're going to create. If you assume you're only going to have a fixed number of tests in your project, you only have a limited supply of keystrokes to add tests to your game, make sure you're adding the right ones by thinking about what we talked about earlier. What's the smoke test that QA is doing? What's the stuff that's would be catastrophic for it to be wrong in a build, that would be really obviously wrong in a build for a human to look at? And so we don't want to waste their time by giving them a build that's obviously wrong. And then secondly, what's really valuable to the player? What's really valuable to you as a team? What are the most important features in your game? Maybe start looking at testing those. And then thirdly, what's the areas of the game that's really difficult to test, that's really hidden away, that takes a lot of button presses, that takes really complex setup? Look at trying to automate those.
Yeah, and I like the process of going through that, even just like those basic things like it launches, right? The player can move and stuff like that, because again, it's something that might seem really obvious, like, oh, I could test that on my editor, that wouldn't take very much time or whatever. But what's nice about it is because it's automated and repeatable, you might, for the first half of development, run that test every single time, no problem. And then maybe like this input thing we saw with Lyra, maybe an asset gets changed or deleted, and then now all of a sudden that's no longer validating. You catch it very easily without having to send a shipment off to QA for them to just go, doesn't even launch, here's it, have it back. It's very important and quite smart.
An ex-colleague of mine was telling me a horror story the other day where he works for an indie publisher in QA and as a QA manager, and he was telling me that they had set up an expensive play test and they got everyone into the room, and then they were bugging the developer over and over and over. They were like, where's the build? Where's the build? Where's the build? And they were like, any second now, any second. And like 30 minutes before the playtest was due to start, a zip turns up. They open the zip and there's 0 levels in it. Like it exists as an exe. You can launch it. And then the main menu is just like, has no levels and no content to play because they've just forgotten to include it. They haven't got a repeatable build process, and they haven't got any automation to check that build was good after they made it.
Oh no.
What a waste of everyone's time and energy.
Yeah, it's a great example of how that would very easily catch that and hopefully avoid that. But it sounds like that was something that was coming in at the last possible minute anyways. So even if they found it, it might not have helped in that instance, but it's still important.
Yeah. It's indicative of there's deeper problems maybe in that team.
Yeah. The last question we have here before we can move on was, my number one problem is usually data assets or other assets failing when the game is packaged. Are these tests able to run for the packaged project?
For some of these tests, yes. It's interesting that you see that as the main problem. In my experience, in a whole bunch of game engines that I've worked in, including Unreal, it's not been... When I'm testing gameplay stuff, if the gameplay stuff works in the editor, it tends to work on console and it tends to work in builds. I'd be interested if there was some more... There's a deeper root problem there that's causing those data asset problem. Like the data asset stuff definitely only works in editor. It's only there before you package your game up to check the data that's going into the game. Spec and everything else can be set up to run in your build. 100% can be set up to run in your build. And the actor tests we're going to look at in a second can be set up to run in your build. I've just not seen that much value from it. If the build gets produced and those tests are passing in editor, then it's normally, unless it's something around specific console-specific input stuff, then there's value in running it on device. Or it's something that you want to interact with specific console API layers. Like you want to, you 100% want to ship your mobile game having an automated test that checks that the IAP is working, right? It's really important that you don't ship a mobile game that doesn't have functional IAP. So having that stuff working on device, really, really important. Making sure that that game on device also executes all the gameplay tests. I've seen that have less value. It might be that their specific project has a situation where there is value to that. That excludes as well performance tests, which are another class of automated test that are looking less for pass fail, less for like there's a specific problem, and more for, hey, we're over a memory threshold or we're dropping frames here. And those kinds of tests, obviously, incredibly important for you to run a device.
Yeah, I mean, that was another question we did get. I was going to save this maybe towards the end because it felt a little bit more general like that. But there was, you could run minimum requirements, but it would run, but it would look, and perform pretty poorly. What is the specs version for low performance or crashing?
Raise that question again for me.
Basically, the question is like for a performance version of this. Like, obviously, we're talking about validators in the sense of like, does it function? Are we having errors and things like that? Is there any sort of validation in terms of performance in a similar way to this?
Yeah, so you would, in the similar way that we created that spec for the smoke test to launch the game and go through different levels, you could extend that and start doing your own validation within that. So you get your own performance capture. So get to a certain point in the game. Where's our thing? We get to here, we're dwelling in gameplay. So we could have a step here that turns on performance capture, waits for a little bit, teleports us to a couple of prefixed points in the levels, continues the performance capture, ends the test. The important thing, and also Unreal Epic has a new plugin that I can't remember the name of, I'm sorry, that is specifically about performance capture. It's still in beta, I believe. But I've seen a couple of talks about it and it looks really, really interesting. Really great surfacing of stats in a really interesting way, and really easy for you to programmatically, for designers to go in and set up performance captures in different areas and get lots of, it looks really good. It looks really good. You should check that out as much as you should use Spec to drive it. But the important thing when you're doing performance tests is that it's not pass fail. It can't be, all of your other tests should be, test has failed, stop the build. Whereas a performance capture, because it can be difficult to trace something. You can imagine a situation where it's a death by 1,000 cuts, right? Where you say you want to fail the build when it drops below 30 FPS, and someone pushes a very small change that then drops it below 30 FPS, drops it to 29.9 FPS, and then all of a sudden the build's failed. And actually fixing that might be an enormous amount of work to go through and have a look at that. So it always should be advisory that the performance metrics are not being met, but you also always need to be keeping a close eye on those things. So you don't get into the point of the game is shipping next week and the performance metrics are suddenly suck. Like, you should be keeping an eye on those and saying, hey, if you can have your system set up to say, hey, there was a big spike, there was a big delta here, that's something you should look more closely at. And then also here's all the historical data, so you can see a trend over time for how metrics getting worse as people are throwing assets into the game. It's a really interesting, really useful thing to be doing on a ton of projects, performance capture.
Yeah. One last little thing I'll say here real quick. I just saw another message in chat. It said, if gameplay works in editor, it tends to work in game. Maybe if certain practices are in place, but it's never been 100% reliable for me. Package issues are definitely a big surprise gotcha.
Yes. Yes, when it comes to like, am I making sure my levels are packaged? Yeah, I can see the justification for if you're particularly in as a bare minimum, right? Your build server could be building the PC game already. It could run the smoke test once the PC game has been built. Run the smoke test on that a second time. As that gets long, you're gonna have to start making compromises, right? You want to be told as soon as possible that there's a failure. So you don't necessarily want to wait for a 45-minute build before you run your smoke test. So you're going to run your smoke test in the editor beforehand so you can get informed more quickly. But then if you also run the smoke test afterwards, then you're making your build times really, really, really long. And so you can start looking at stuff like quarantining, like what's the word, tiering. So you can say these tests we're going to run on every push. These tests we're going to run on every build, which might be once or twice a day. These tests we're going to run every weekend. And you can split things up. So you're still getting some of that benefit of running these more expensive tests multiple times, but you're not running it at as high a cadence as some of your more useful tests. So eventually you will get told within a couple of days, you'll be told someone's messed up the packaging and all of a sudden the levels or this blueprint is missing or this level's not being packaged properly. You get told, but it will just be a few days later.
Mm-hmm. Awesome.
And that lets you keep that lets you keep really responsive, really fast builds.
Yeah. Perfect. Well, that's pretty much most of the questions we have for the moment. So if anybody else had any questions, feel free to put them in chat. But for the in the meantime, let's get to the next section.
Yes. So we're going to look now at the last group of tests that we're going to look at, which are actor tests. If people have heard of automated testing before, they've probably heard of unit testing. One of my the things that irks me sometimes is when people just call any kind of automated test as a unit test. And a unit test is a very specific thing, right? A unit test is a test that aims to examine one piece of functionality in isolation. Whereas our smoke test, we're saying, does the whole game run? Our validation test, we're saying, is this data on disk look correct? A unit test is saying, hey, does this individual system, when we poke it by itself, does it give us the output we expect? Which may or may not be even something that's player facing. Unit tests traditionally are very hard to do at in game engines because they require, by the default, they're saying it's not a unit test unless you've isolated everything. And it's really difficult for you to take a blueprint and test it in isolation. It probably needs the physics system. It probably needs the asset pipeline. It needs the renderer to be running. So you're bringing all these dependencies in, which means that your unit tests are not as isolated as they could be. And Sea of Thieves tackled this problem. So this is a term from Sea of Thieves, from the team that did amazing work on Sea of Thieves. They came up with this term actor test that they've used in a bunch of their documentation. And this is about best effort to reduce dependencies. So this is as much as we can to make a unit test. And it's kind of making a unit test with our fingers crossed behind our backs, right? We promise it's a unit test, pinky promise. And you might say, well, why not just call it a unit test? And I think it's useful to have this language of saying actor tests around it so you can understand going in the context here is that this is going to be runtime, this is going to have some dependencies, but we've worked as hard as we can to minimize them. One really great way of approaching actor tests at runtime is ring-fenced regressions. This is a technique I've used in the past. Ring-fenced regressions means we're going to look at our game and we're going to ask ourselves, what's fragile? We've talked a little bit about this already. What's fragile in our game? What's always breaking? Or what's really, really, really important to us? What's a core pillar of our game? And whatever area you're looking at, you're going to draw a ring fence around it. And you're going to say any bug that falls within that ring fence, we're going to fix with tests. So what we're not going to do is construct tests for new features or new systems, but we are going to say every time a bug turns up, So a regression, a bug has appeared, our features have regressed. Then we'll go within that ring fence, we're going to create an automated test to fix it. And that will help you very quickly build a very useful suite of automated tests. And I did this for a project I was the lead on a couple of years ago called Rollerdrome. Really fun game with very complicated character controller, right? So if you've never played it, it's Tony Hawk with guns, or it's Doom on roller skates. So you can do all the stuff you can do in Tony Hawk. You can grind, you can vert, you can air out, you can backflip. You can't do that in Tony Hawk, but you can acid drop, you can do all this stuff, which meant we had a very, very complicated character controller with a ton of different transitions coming in and out, all these state machines, stuff leaning on each other. And it became really, really fragile very, very quickly. I joined the project at Greenlight, and we were already in the situation where in our 6-week milestones, we were saying for the last 2 weeks, please stop working on the character controller, because it takes QA 2 weeks just to explore the full feature set and find everything that we've broken for our external release, which was untenable, right? If you can't work for 2 weeks of your 6-week milestone, you've lost 1/3 of your development budget. So we started doing ring-fenced regressions very, very quickly. And that meant that every time there was a new bug with the character controller, like verting between these 2 quarter pipes causes a bug, or acid dropping from this thing into this particular quarter pipe causes a bug, or wall riding into a grind is causing a bug, we would fix that with an actor test. And that actor test would exercise that bug and make sure it never came back. And then very quickly, very, very quickly, this corner of the game, which is incredibly important, it's half the game, it's about roller skating and shooting. And this was the roller skating bit. Half the game, really important. And it went from the most fragile part of the game to the most stable part of the game, to the point where we were doing ridiculously deep physics optimizations really, really safely, very, very close to launch, with total impunity, because we had the tests to back us up. And this is we looked at Sea of Thieves slide earlier with their bug count. This is my version of a slide for Rollerdrome, which is the serious bugs in the last 6 months of development on 50% of the game. Right? The character movement system. These are the serious bugs. And these are not bugs created. These are bugs open. So you can see here in November, we made 3 bugs in that month, and we fixed them immediately. And this is, to be clear, bugs that QA got to see. So I'm sure we're making bugs. I'm sure we're making bugs in this period. But the build system is catching it. The automated tests are failing it, and QA never see it.
Yeah,
it gets caught, it gets fixed.
3 bugs for a month is not a lot at all. That's quite impressive. That's quite impressive.
And then no bugs for like 4 months here. And I promise you, we're working on it in the run up to alpha. I think alpha was like around here. Like, we're working on it and we're doing stuff, but our increasingly large test suite is capturing all the issues and letting us move fast, right? Took a little bit of effort to create this stuff, but we're moving so fast now and making deep fixes. And at no point did anyone on this project on the character controller say, that's too risky to fix, right? Which is a sentence I heard all the time on projects before that, of saying, I'd love to fix this, but it's going to cost us so much energy to test it afterwards that we can't afford it. And in this situation, with the tests supporting it, we didn't have to say that. We could always say, yeah, well, we'll do it and we'll see. And if the tests pass, then we're good. And if one test fails, we'll debug it and we'll fix it and we're probably still good. So that's actor tests. Let's look at a demo of that. What we've got I'm going to go back to the gym. These are weapon spawners. So when you enter gameplay, you should be able to run over these weapon spawners and pick up this assault rifle, but they're not working. Nothing's happening, right? And you can imagine that QA would pick this up relatively quickly, but you can also imagine situations where it takes them a day or 2 to notice. Like they pass the spawner and they're like, oh, maybe I just didn't clip it right. Maybe in Lyra, they're going to notice it fairly quickly. But you can imagine situations where it just doesn't get noticed. And the game ends up in a bad state for a while. So it'd be really nice if we can make an actor test that made sure that whenever we had a spawner, we were able to pick it up quickly and easily. And so to do that, we're going to use CQ test, which is the one of the newer automation frameworks in Unreal. And this is the one that came from Sea of Thieves. So Sea of Thieves created CQ test, and they merged it up to to Unreal, and Epic was kind enough to work with them to integrate that and then give that to everyone who works with Unreal, which is fantastic. So we make a new test class here called spawner tests. We've imported CQ test at the top. It's macros again, but they're different macros to spec. We've got test class with flags, and we're able to give a name of a test. And again, you see these ... dots that tell us how to put it into the automation window. And then this looks a lot more familiar. It looks a lot more like a class than spec does. Spec, it could be a bit confusing about what's inside the class and what isn't. We've got curly braces here. We can create member variables. We can create helper methods. And then we've got a before each. We saw after each previously in spec. So it's a helper function that runs after the tests run. And then we've got test method. And test method takes a parameter, which is the name of the test. This is using a naming convention that's relatively common in automated tests called given, when, then. In given, when, then, between the underbars, you get these different sections. So given that we're testing on begin overlap, when a player enters the collider, then the player inventory receives a weapon. That's the test name. That's the thing, the scenario we're describing here. Because if we go and look at the actual problem, which is in Lyra Weapon Spawner, because it's always best to debug the problem before you start writing tests on it. Lyra Weapon Spawner has an onBegin overlap function, which you'd expect. It's hit some sort of collider. It's been past the player that's entered. And then the test here is, are we the server? Do we have a weapon available? And is the overlapping pawn null? And this is the bug, right? This should be not equals to null. So someone's just typoed this. And if that happens, then we can pick up the weapon, right? We could just do that and we're done, right? And we could close the bug. But instead, we're going to write a test with this fix. And by doing that, we're going to help make the game more stable in the long run by having these tests that are constantly reinforcing these features that are important to us. So here we've got our before each, our setup stuff here. Our before each test is doing some lazy loading. So again, we're seeing a latent command builder, the same as we saw in spec. And here we're making sure that, so this line here is telling it, please load the test level, which is defined in this variable here. L shooter test basic, which is an empty level that just has a floor and some lighting in it. So we're trying to remove dependencies as much as possible. And one of those things to remove dependencies is don't try and test it in that gym that we saw with so many other things flying around in the air, because we don't want our test to fail because one of those other things we don't care about is broken. So we'll load into an empty level, which will try and isolate it as much as possible. We are going to wait until we have a player, and then we're going to fetch some things we need out of the player. We need the inventory because we need to know if they pick the weapon up or not. And then the code, for this, again, is going to look like a latent test. It's going to use the test command builder again, because we need to do this multi-frame testing, which is going to involve us using a latent builder. We're going to get the weapon that we expect out of the item we're testing. We're going to get the initial weapon count from the item. Then, first of all, we're going to set those values here. So we created them. We had to make them shared because they're going to live outside, across multiple frames. They're going to live outside of this method. So we're going to allocate them in such a way that they can survive leaving the stack here. As soon as we load into the level, we're going to populate those values. We're going to spawn a weapon spawner near the player. Then we're going to wait a couple of seconds. We're going to walk the player into the spawner, which just looks like doing a set actor location. We're just going to teleport them. We don't have to. We could have used the input system, but again, that's adding dependencies. If the input system was broken in any way, our test about the weapon spawner would be broken. And our weapon spawner has nothing wrong with it. It's just the input system that's broken. So we're trying to avoid that by just teleporting. We're going to teleport into the weapon spawner. We're going to wait a second for that to do its thing. And then we're going to assert that the player received the weapon. It received exactly this weapon with exactly this weapon count. And if we then compile and run this test, we'll see it appear in the automation window, in the automation tab of the session front end, and then we'll be able to execute it and hopefully see it fail. Now, this is an important thing. We know where the bug is. We know the bug is a missing equality operator, not equal operator. We could fix it while we're writing the test, but it's extremely important that when you're creating test automations, you test your tests. And that means seeing them fail. And it means seeing them fail for the right reasons. So we are not going to fix this bug until we're happy with this test. And only then, once we're happy, will we go and actually fix the code in question. Which means when you're doing stuff like writing smoke tests, we wrote these smoke tests before. We saw one of them fail because we had an existing bug. If we hadn't have seen that, we would need to go in and mess something up with the production code to make sure that our test failed for the right reasons. So we can, because we can't write tests for tests. We have to just test them manually. So here's our actor test. Here's our weapon spawner. Here's our weapon spawner pickup test. We're saying on overlap, given on overlap begin, when player enters, player inventory receives weapon. Now this is going to run relatively quickly. Spawn, teleport, don't get the weapon, test fails, right? We've got the player did not receive the spawner's weapon after walking in, and we have a marked test failure there. This is good, right? This is a working regression test. It is in a file that's 100 lines long, but a lot of this is boilerplate that will work for your future weapon spawner tests. So it's not just one-time stuff. The actual test itself is only really this stuff. But it's not the best we can do. We need to make best efforts to reduce dependencies. And we still have dependencies here. We have dependencies on the player walking into the teleporter, on the physics system, recognizing those colliders collide. We have dependencies on the player inventory. The inventory needs to work correctly and receive the weapon for this test to pass. And so we can do better. We can refine this. And the next thing we'll do, one of the things you'll learn, unfortunately, I'm a big fan of hot reload in Unreal, but you will learn when you're working on tests that for some reason it does not work with tests. You can hot reload as much as you like and it will say it passes and then the tests won't refresh properly. So our next version of this, I do have to quit Unreal and rebuild. Our next version of this, what we're doing here is, because this uses the game playability system, we can dig into the way that the weapon spawner is working, and the weapon spawner is broadcasting a weapon pickup gameplay queue. And so we don't have to listen to the player inventory anymore. We can just listen for that gameplay queue. And so we cut out all of the player inventory, we reduce dependencies, and now we're just binding to that gameplay queue. And then we've got this B heard queue variable, and that will go true the second that the player receives, the second that the spawner sends out that gameplay queue to the player. And so from an appearance point of view, that's going to look very much the same to you. It's going to spawn, it's going to wait, it's going to teleport, nothing's going to happen, and the test is going to fail. But we know behind the scenes that we no longer have a dependency on the inventory system. We can throw as many bugs as we want into the inventory, and this test will still be failing and passing for the right reasons. But we can still do better, because at the moment we're still teleporting the player. We're still relying on the physics system. And actually, the weapon spawner on begin overlap is a public function. So rather than teleporting the player and asking the physics system to recognize the player's layer, collide that bounding volume against the spawner's bounding volume, compare their layers, and then send the on begin overlap, we can just call on begin overlap ourselves. We never need to move the player at all. So we'll do that. And in fact, this time as well, I will fix the bug. So here the bug is now fixed. So this test should pass. And our final version of the spawner test, when it says overlap player with spawner, actually all it does now is get the weapon spawner that we already have and call onBegin overlap with the player that we know exists. In an ideal world, maybe there's even a universe where this is not even a real player. All it needs is a pawn on the right layer. So maybe it can be some kind of fake player. We don't need to instantiate the entire player actor character controller. We can just instantiate a very dumb pawn that has the right layer and one probably doesn't even need physics. It just needs a player to exist, a pawn to exist of some kind. And that gets rid of even more dependencies from our tests, and our test is even more isolated. And we're closer to that ideal of a unit test that's only testing the one thing, only testing the one bit of external behavior. Okay, this will be our last actor test.
This one's going to work.
Yeah, yeah. And it should pass. It should pass this time. Wait.
Hey.
He's got the gun. He didn't move. He just stayed where he was. And the test passes. So that's all the tests I'm going to show you. And we wrote, like, these asset tests, I wouldn't recommend you use in production, but I showed them for you an example. The unit tests we didn't cover today, but we cover in the bigger workshop. We wrote smoke tests for the front end. We wrote, I skipped over these smoke tests, but these are really useful. Let me show you these. So these take every single weapon in the game, discover them programmatically. So as soon as someone creates a new weapon, it starts getting tested. And it checks that it can equip without error, fires once without error, empties the clip without error, and then reloads without error. And so you see spawn into an empty level, fire the whole weapon, reload, next weapon, and it should cycle through everything. And that will capture quite a lot of issues with your weapon systems without you having to write a tremendous amount of actor tests for them. You just have to write this one high-level smoke test, and it gives you coarse granularity, but it gives you some coverage. Yeah, that was a whole bunch. Let me wrap up the actor tests for you. So we saw an actor test. We're trying to isolate as much as possible, and one way of doing that was using minimal scenes, removing dependencies as much as possible. If we can identify ways to skip whole systems, then we will, to try and get to that point where we're just testing that one bit of code in isolation. And it's really, really great for regression tests. For you have a bug that you know exists, you can go and create an actor test for that specific bug, and then you know that bug will never come back. We used CQ test to do that. We saw it has lots of helpers. We didn't go into it in great detail. Object builder helps us spawn a Lyra weapon spawner in the right place, sets the parameters on that object really easily, and then spawns them in the right place in the world. These are all useful tools that exist within CQ test coming from Sea of Thieves. It's got a more traditional setup. If any of you have used XUnit style test frameworks like JUnit or NUnit, this will look more familiar to you than the BDD style of Spec. But its one big weakness is that it can't do those procedural tests. So you can't use it to programmatically discover every weapon. And so the weapon smoke tests we were writing using Spec because we wanted that functionality. We'll skip over the slide. And then within our matrix, we saw asset tests going back all the way back to the beginning. Asset tests are really great for data on disk, for stuff that you know you don't have to run the game to check. They can execute really, really quick, and you can make a lot of them very, very quickly. Smoke tests are really, really great for giving you a huge amount of coverage very, very fast. You give a lot of bang for buck from a smoke test, but they don't give you that fine-grained information. They just tell you something is wrong. And then our actor tests are going to go in this top right here. So they're still slow to execute because we're running them at runtime. I told you before, one project I worked on had 30 minutes of smoke tests. It had also 30 minutes of character controller tests. So we're talking 1 hour of test automation. And then it had another 30 minutes of enemy tests. So 90 minutes overall of test automation running at runtime, which gave us a lot of coverage and a lot of security and a lot of usefulness, but we're paying that cost in terms of build latency. So actor tests are going to be slow to execute, but you can still have a lot of them right? Because we're talking about very specific things. The player will get this weapon from the spawner. The spawner is successfully given items. It's not that something's broken, check it out. It's very, very specific.
Because these tend to take, a significant amount of time, is this one of those things that you recommend kind of running like end of day, basically before leaving the office sort of thing, so that way when you come back, you can see what worked and didn't?
Yeah, you might approach, I would have the smoke test running every build. So most teams are only going to be making a build once or twice a day. So once or twice a day, we're running the full suite, right? So 90 minutes on top of your build time, which might be 60 minutes. So 2.5 hours to produce a build. But that's a scheduled thing. So you can start it early to make sure QA are getting it for lunchtime or whatever. And then throughout the day, and this is compute time as well. So with a good build engineer, you can parallelize this and have 3 machines running 30 minutes of test each. So actually it's only a 30-minute addition on your build time. But then throughout the day, we're running it regularly. So not running on every commit, but maybe every few hours, it's running all of those tests. Because one thing you want to avoid is, and this will happen, is it gets to 5:30 p.m. and someone pushes a change and then logs off, and that change breaks the overnight build. It fails one of these tests. So that, again, test automation and build engineering is as much about team and processes as it is about writing tests and failing builds. And so it's training the team to say, if it's 5:30, you can wait to push it to the morning. And then you've got all day to wait for the build and to fix it if there's a problem. Push it at 4 o'clock, push it at 3:30, push it when you're going to be around for 60 minutes to make sure this can get through all the tests and pass. So that overnight build we know will succeed. Yes. Yeah. And that was actor tests. And that was all the tests we're going to look at. I hope you agree, having gone through all that, automated testing is a tool for catching bugs much faster, which saves you time and money. And it doesn't matter what budget you've got, and it doesn't matter what genre you're working in or what platforms you're working on. Test automation, a sensible amount, a pragmatic amount of test automation can work for you. I'd love to hear more questions and discussion. Before we do that, I'll leave you once more. I'll mention you can contact me for work to help with your team. And you can go to the workshops section now if you'd like. We do a 4-week version of basically what you've seen today, except we're doing much more work, working in a cohort together, setting you homework and doing assessments and teaching you what's a good test and what's not a good test and teaching you how to code review tests. So you really come out of that being an expert in creating test automation. And then finally, I want to leave you with a bunch of links. I run a automated testing in games community. We have a Discord. So if you go to atig.dev, you can join our Discord. If you want to talk more about test automation with fun people, you can reach me on this email, and you can find those workshops there. And then lastly, if you go into Gamescom next week, I am running a meetup there at Gamescom on the Thursday for anyone who's interested in test automation or build engineering or enthusiastic about it or wants to learn more about it. You're more than welcome to turn up at the meetup. That's on Thursday afternoon at 5 o'clock, if you're lucky enough to be in Cologne. And that's it. Now, I want to hear what chat thinks, how excited they are or how angry they are at all the extra work I've given them.
No, actually, everything's been very positive. A lot of really good feedback. I had to shout out somebody who wrote Rollerdrome when you put that on screen, because definite hidden gem, that one. We have a handful of questions here. This will also be a good reminder too for folks who are tuning in live. If you have any questions, I know we're getting pretty close to the hour here, but we can stick around for just a little bit longer to answer some of your questions. Leave them in the chat. Bracket question followed by your question, and we will try to get through as many of them as we can. One of the questions we had here was, how high is the ramp up for other teams to get into test automation? Are there areas where tests simply will not work?
I think that the closer you get to visual stuff, the harder it is. So testing UI is a constant. Not only is it one of the things people want to test most, because they don't want to ship a game where the main menu button is completely missing, but also it's one of the hardest moving targets because it will churn constantly. Like your UI will change, will get thrown out and rebuilt 5 times during your project, probably. And so you're going to have to rewrite those tests constantly. The people changing the UI won't be engineers, maybe. It might be UI artists and UI designers, and they're going to move stuff around without understanding, excuse me, that there are tests backing it. And so you'll get, they'll do work and they'll see a test failure which looks really scary. Everyone will start freaking out. The build will stop running. And really what they need to do is go and update the tests. There are tools that you can use. Game Driver is a company I've done a bunch of work with. They have solutions for Unreal, which can let you make more secure, more reliable UI based tests. For instance, our smoke test earlier could have looked like us clicking that main menu button directly and clicking the next button and going through that way. And it would, if you knew that your tests were reliable and sustainable in the long term, that will give you really good security that your UI is working as well as it can, as well as your other systems. But for most people, I think it's not the lowest hanging fruit. That stuff, visual stuff like animation, visual effects, trying to test, for instance, that the muzzle flash on my gun is working correctly. That's the stuff that's best left for human eyes. Or rather that investing in automation to get at those things is going to be a big hill to climb. You could do it. Teams do it. You have to do it with your eyes open. The lowest hanging fruit that new teams, new to automation, should be looking at is data validation and smoke tests to begin with. And then maybe, if you've got a really fragile area, start looking at actor tests. Is it a big learning curve? Yeah. No. It's a skill. It's a new skill, right? It's creating a good test is as much a skill as creating good gameplay code, good reusable gameplay code. It's not something that you want to outsource to Claude, for instance, without knowing what you're doing. It's one of the things that terrifies me. And this is the classic, and I'm sure maybe you've got questions about AI, but this is the classic thing people say about AI. It was like, people say it's really good until it starts working in their area. And they're like, oh, actually, it sucks for my thing, but it's good for everything else. And I've seen too many people say, oh, I just asked Claude to write some tests and now I have tests and now I'm good. And then you look at those tests and the tests are testing themselves, or they're testing the wrong thing, or they're testing the mock data. And unless you go through the effort to understand how to code review those tests, which basically means learning how to write tests, then you won't get the value out of asking Claude to write tests for you yet. Maybe one day that's going to be good. But I think if you want to get into test automation, I think you can do a bunch by getting some books and do some learning and do some reading and watching some talks. atig.dev, the automated testing games community I run, on their website, we have a Trello page that's got an enormous amount of resources, talks and books and articles all about test automation, and you could teach yourself a tremendous amount from that. I've mentioned my workshop, so I'm available to help get teams over that hump as well. But it's not the only way of doing it. I didn't use a workshop to teach myself test automation. I taught myself test automation by learning and doing and failing. My second GDC talk, my first GDC talk about test automation was in 2015, and it was about how much I messed up. Like, it was about how bad the test automation that I wrote was, and how it was fragile and how it broke all the time. And it's a common story from teams starting to do test automation. They start doing it, and then after a while, they get to the point where they find themselves spending more time fixing tests than they do working on gameplay code. And that's probably because they've made some very common, easy to make mistakes that I made in that GDC talk. So you should go and find that GDC talk, and that will give you a grounding to help you learn not what to do. And then when you get a publisher deal for your game, then you should contract me and I'll come and teach you what to really do.
I love it. Another question we had here was, can you talk about organizing tests using the pretty name or test tags? Kind of general, but...
Yeah. So there's... how do you do it? I'm not sure how you do it in CQ test, but you can. We saw that you were able to put tests into different categories here. We can put flags and categories here as well, and they'll allow us to split the test library in interesting ways. So we're able to say, for instance, we're able to get our build server to run all of the actor tests. We can say only run stuff under this hierarchy, and that will run all the actor tests or run all the smoke tests for us. Please run all the player tests over here. Please run all the enemy tests over here. Do them in isolation. And then we can split them when it comes to how complex those testers are. So we can say, please run the actor tests that are smoke tests, which are some of these more automation test flags. Automation test flags. Yeah, so we've got high priority, low priority. We've got a bunch of product filter is a very common one. Smoke filter, stress filter. Unreal has some, Epic has some questionable language around this. So their version of a smoke test is a very, very, very fast test. And my version of a smoke test is a very, very, very slow test. And it's just a language thing. So investigate more of what these categories mean. But if you can tag something smoke test photo, and that will let you then ask set up your build server to run different slices of your test in different situations. So you can start to do what we were talking about earlier in terms of having some tests that run overnight or at the weekend, and having your more high priority, faster tests run multiple times a day. I hope that answered that person's question.
Yeah. And I'm actually seeing a little bit of conversation in the chat after the previous question with the AI side of it. And I think it's worth kind of reiterating here. The AI could help you, in theory, build these tests, right? But without the knowledge of what's actually happening here, you're at the whim of the AI, right? Like sometimes AI is really good at doing its job. Sometimes it doesn't quite hit the mark. And if you don't have the knowledge for how to fix that or test that or check that, you're really kind of rolling the die with that. But having some of these foundational skills and stuff will really help you be able to look at that code and be like, okay, maybe, oh, I see why this isn't working and things like that. So
yeah,
it can be a bit of a shortcut in terms of like maybe getting you something that's like there now. But you're also going to want to have at least the foundational understanding. That way you can address any shortcomings that is, generated by whatever you're using.
Yes, 100%. And some studios have asked me, hey, can you come and teach us how to use AI to write tests? And I've been like, sure, you're going to pay me. It's fine. Like, I'll do it. And what that looks like is basically, I basically teach you how to write tests. And at the end, I say, now put this in Claude.md and then code review what it produces. Like that, like there isn't a super shortcut. You need some person in your team who has a decent, it doesn't have to be a world expert, right? But some decent understanding. You've got a taster of it today, a little bit more learning beyond this, and you won't be a million miles off being able to code review what Claude produces and making sure that it's doing exactly what it wanted to do. And then the magical, powerful thing here, this is one of the frustrating things about, there's a ton of frustrating things about AI, right? But one of the things is that I've seen a bunch of people get really enthusiastic about test automation all of a sudden because they're like, oh, we can iterate so quickly when we got test automation. I'm like, yeah, I've been saying that for 10 years. Like, now, just because you're pumping tokens into it and you're paying $200 a month for the privilege, you're suddenly very excited about doing test automation. But yes, if you have that, there's a possible future universe where the thing that you really care about is the tests. You care about the requirements that you're putting into these tests, and then the quality of the production code, because we all know Claude can't really manage an entire code base by itself. But the quality of that production code doesn't really matter if your tests are passing, right? If you're able to maybe with Claude and then review what Claude's doing, but build a good comprehensive test suite for your game, then you can let Claude do whatever the hell it wants to do with your production code, refactor it, jigger it around, move this block over here, add all this coupling. It doesn't matter because it will operate really, really quickly, and then it can run its tests. And if the tests are telling it it's all passing, then it's being successful. When the tests are telling it's failing, it'll keep jiggering and poking and tweaking stuff, and it will get you a result. And then maybe that's a universe where you're doing less. Maybe that is what software engineering in games looks like in the future, is being an expert in test automation and working with Claude to create the tests so that Claude can then write the game. Who knows? Who knows? But I don't think it's going to hurt your career prospects if you learn how to do this stuff.
Yeah, I think understanding the foundations for anything that you're going to have automate through, I mean, basically any means, but especially with AI, I think is very important, right? Because, like we said, it's going to do the job, and most of the time it'll probably do a fair enough job. But every once in a while, or maybe more so, depending on what you're doing, it might not. And if you don't know what you're looking for or why or how to fix it, I mean, you know, you could end up just going in circles saying like, well, it's doing this, but I need to not do that. But because it did it in the first place, it's probably going to do it again because that's what it thinks it's supposed to do. So
Yeah.
those foundations are really important for just about anything. Another question we had here was, if the weapons are added to the list of tests programmatically, is there a risk that they will also be automatically removed from the test list if someone accidentally deletes an entire weapon?
I guess. Yes. Yes. I mean, at some point you need a source of ground truth, right? And if you can't trust your file system, your tests are never going to give you 100% code coverage of every single problem in the entire game. At some point, because it's not a replacement for QA. We said that at the beginning. It's not a replacement for QA. It's about freeing QA from the most monotonous tasks. And so having QA then able to say, hey, we've got a build and all the tests passed, but it's missing the pistol. I think that's okay. I think that's not a sign that there's a hole in your test framework as much as it's a sign of the test framework of your setup working as it should be working. But they're right. That is a hole, outside of the scope of those tests. Let's say.
I think it's worth emphasizing, right? Like the goal here is to have it catch as much as possible, but it's not realistic for it to be able to catch every single thing in every single instance, especially if you hadn't thought about it in advance and planned for that sort of thing. You're always going to find stuff. I mean, I'm sure you could list 1,000 different examples where it's like the end of production. You're like, oh, this would have been a good thing for me to add to that test list. I should have done that before. Like that. It's just the natural form.
Yeah, but the flip side of that coin is that person could think, well, what if someone deletes my game? And then they could add a test. What if someone deletes a weapon? And they could end up spending time adding a test to verify the list of weapons. And then that test never fails because no one ends up ever deleting a weapon. And if any test that you write and never fails has produced very little value for you, it's much better to choose tests that you know will have a plausible reason for failing in the future, especially understanding that you only have a certain limited number of tests that you can write. Like, given your budget and timeline for your project, you're only going to be able to create so many tests, and you only want to create ones that you know will give you value by failing. The ones that pass will give you some tiny bit of value. They give you some level of confidence that the game is working. At least these tests are passing. They don't always mean that the game is working because someone might delete a weapon or something, right? But yeah, you want to make sure the ones you're writing for good reasons that you think will actually fail, will actually provide value, not because I've thought of some speculative reason of things someone might potentially do in the future. I mean, maybe this person's been in a situation where someone's deleted a weapon. Fantastic. There's a plausible reason for you to create that test, but do make sure you're asking yourself that question beforehand. Is this actually going to fail?
One of the last questions we had here is kind of an interesting one. It says, as a solo dev, how important are these tests, given that I do everything from UI to game logic?
I think important. I think no less important than any other project. Like, you do not want to, like, you want to be pragmatic, of course. You want to make sure you're providing tests with value, but I mean, maybe the thing they're getting at is they understand the whole system anyway. They can test the game every time they make a change. They can test the entire thing from beginning to end. Sure. Do you want to spend your time doing that? And do you want to have to keep the entire game in your head for the entire lifetime of the project? Or would you rather be able to outsource some of these constraints to code that can execute consistently and repeatedly for you? That's what I would choose. I would choose doing it using the metrics we've already talked about. Like, let's make some smoke tests and then never touch them again. Let's make some actor tests for the really high risk areas of our game. For maybe the one highest risk area of our game, we'll make some actor tests for that. And then everything else we'll leave it to nature's laws. But yeah, I still think a solo dev can get a lot of value out of test automation.
Yeah, and I would even argue, and be curious to hear your thoughts on this too, is like it might almost be even more important because you're solely responsible for absolutely everything, and there's a very strong likelihood, unless you have like perfect memory, there's very strong possibility that you'll work on something, let it go for 3, 6, 12 months, do something else that affects that thing. It was working before, but it broke now, and now you have to go all the way back and remember what you did at the time and do all that sort of stuff. Like you're asking a lot more of yourself, especially from just like a disciplinary standpoint, right? Like you could be extremely proficient in, a handful of sections of a game, but to be extremely proficient in every single task, there's people that have been doing this for 40, 50 years that probably couldn't even claim that, that level of proficiency stuff. So those tests kind of help keep track of those things where you might have, fallen short a little bit, or you forgot, or whatever, be whatever have you.
Absolutely. Yeah. The past is never country, right? Like 6 months ago, you was an idiot who wrote bad code and you hate them. I don't trust that person. I want to have tests for that person.
My favorite one is I'm getting into the programmatic side of it. I've been an artist, environment artist for too long. I don't want to talk about it, but I'm getting into the programmatic side of it, and it's amazing when I'll work on something. It'll be like 4 days later, and I'll look back at my code, and I'm like, "What was I doing?" That guy, yeah, like you said, that guy 4 days ago was an idiot. Like it's amazing how quickly that happens. So. Well, that's pretty much it for the questions here. Andrew, thank you so much for joining us and coming and bringing all this. I did have one more really important question, which is what exists in that bottom left quadrant of that matrix? Because I don't think we put anything in there.
No, like fast to execute, but you have a feeling it doesn't really get populated. Maybe I should go into the science lab and try and invent.
Yeah, you got to find one example just so it's there.
Yeah.
No, well, I really appreciate you taking the time to come here and talk to us about this. Like, this is really important, and chat seems to agree because there's a lot of really positive feedback here. So
Nice. I
really
love talking
appreciate
about
it.
this stuff. I'm so pleased that you invited me, Dan. I had a great time.
Yeah. I appreciate you joining us, and appreciate everybody here at home for watching as well. This show would not be what it is without you, your time, and your questions. So thank you so much for joining us. That will wrap up today's show. If you came in partway through, or you just simply want to go back and watch part of the show, no worries. We post all of our streams in VOD format on both our Unreal channel on YouTube and Twitch. You can also keep up with all of our cool news and shoutouts on our socials at Unreal Engine. And if you haven't already, please head over to the EDC, the Epic developer community, where we have our tutorials from both Epic staff and community members alike, documentation, forums, and so much more. But again, huge shout out to you for joining us today. And we'll see you guys all in the next Inside Unreal. All right, everybody.
Bye.